Hello everybody.
Big hi, from Raj.
Hello, from Aishroy.
Hi, from Venkat.
Hi, from Krish.
Hi, from Hema. Big hi,
Hi,
from
from
Reema.
Don.
Big hi from Mariam.
Hello from Koti.
Big hello from Benny.
Hello from
Hi
Ziffy.
from Randy.
Hello
Hello
from
from
Hariram.
Fine. Can we start?
Yes.
Yeah. Yes. Jiha.
Go ahead.
Ready,
Ready,
go
please
ahead.
go
I
ahead.
am
Yes,
through.
me too.
I am right on.
Okay, from
Mal.
Well, looks fine. Today we will be discussing about string types, operators, and dot methods for manipulating the strings in SystemVerilog. SystemVerilog supports the string data type, to which a string literal can be assigned. String data type is used for storing strings, and are of variable size. A string data type in SystemVerilog is a dynamically allocated array of bytes. Variables of type string will be indexed from 0 to n-1, where n-1 is the last element of the array. Any questions so far?
It would be helpful if you can show the syntax and one example.
Okay, let us look at this example.
I have a question. Is the initial value mandatory?
No, it is optional.
Okay, fine.
To add further, it can be initialized later in the code.
Yes, Venkat, you are correct.
What if an initial value is not specified in the declaration?
I will answer Hi T's question. In this case, the variable is initialized to an empty string.
Yes, Dan is correct. Now, we will discuss about the operators that can be used to manipulate the string data.
Before we jump on to operators, I have a small query.
Ziffy, feel free to raise your query.
Okay, the query is when an element is read or accessed, what does it yield?
I think Krish can answer this.
Yes, I can. In this case, when an element is read, it yields a byte.
Okay, thank you Krish.
Great. Now, I think I can move on to the operators. SystemVerilog provides a set of operators for checking equality, comparison, concatenation, etc.
Does it have operator to invoke built-in methods on the string object?
Yes, dot is the operator for invoking methods on the string variables. For details, let us look at this table.
How does the string comparison works for less than or greater than operators?
The comparison will be done with regard to the lexical ordering.
Okay, the operands can be of type string, or one of them can be a string literal.
Yes, both the operands can be of type string, or one of them can be a string literal.
Looking at the table, as we also support replication of strings.
Yes.
To access the selective character in the string, index from 0 to n-1 can be used in square brackets.
Yes. Now, we will look at special methods to work with the strings. These methods use the built-in method notation. Let us look at this table for few of the methods and their functional description.
So, for example, if my string has 5 characters, then len, that is, len method returns 5.
Yes. On the other note, if string is empty, then lay method returns 0.
Substring method returns the substring, formed by characters in positions I through j, where I and j are indexes.
Yes. Further, let us look at some more methods and their description.
Can we try some example, for example, a to I, or any other method?
Yes. We will write the code for declaring a string type, operator, and a to I, simulate and observe the results.
Okay.
That sounds good.
Okay. Now we will write the code and move on further. Here, the literal assigned is character u, but it is lexically greater, though the length is less than my string.
That means variable test string is greater than variable my string.
Yes. Let us verify it using greater than operator. Here the literal assigned is string bigger in length, but it is lexically lower, though the length is bigger than the my string.
That means variable test string is less than variable my string.
Yes. We will verify it using less than operator. Let us observe the simulated output in the RHS shell.
In first comparison, string with character u is resulted as greater.
Yes, further, in the second one, string which started with character s is resulted as less value string.
This suggests that comparison will be done basing the lexical ordering.
Absolutely correct. Now, let us look at the a to I portion.
When string as it is, that is without a to I printed, it produced the ASCII string as it is.
Yes, it produced the ASCII string as it is, despite it is formatted with binary format.
That suggests it is just a string type.
Yes.
When the string is applied with dot method, a, to, I, on the string, it produced integer type.
Yes, as a result, it produced the equivalent binary and hex outputs.
Yes, I can notice.
Okay, in summary, we have gone through string type declaration, initializing with string literal, one operator, and one dot method. That concludes this session. Thank you all.
Thank you.